Forces. Force is a vector quantity that has both magnitude and direction. Its unit is the newtons. Effects of the forces on object. When forces act on an object, they can cause the object to change in shape, direction of moving, speed. Forces can be categorized into two main types: contact forces and non-contact forces. A contact force is a force that acts between two objects that are physically touching each other. When two objects collide or come into contact, they exert a force on each other. This force can cause a change in motion, direction, or shape of the objects. When your hand pushes the box, a contact force propels the box forward. This is called the pushing force. Normal reaction force is the perpendicular force that acts on an object when it is in contact with a surface. When you place a box on a table, the table exerts an upward force, normal force, to hold the book against gravity. Tension is the force in a string, spring, rubber band, or wire when it is stretched or compressed. When you pull a box with a rope to create tension in the rope, this tension is the pulling force transmitted through the length of the rope. Friction is the force that opposes the relative motion between two surfaces in contact. When you push a box or pulling a box along the floor with a rope, friction acts in the opposite direction of your applied force. Air or liquid resistance, also known as drag force, is a resistive force that acts on an object moving through air or liquid. Upthrust force, or buoyancy force, is the upward force that acts on an object that is partially or fully submerged in a fluid. A non-contact force is a force that acts between two objects that are not physically touching. Non-contact forces act through a field, which is an invisible region of space that surrounds an object and exerts a force on other objects within that field. The gravitational force, or weight, due to the gravitational field strength of Earth. Its direction is always downward. Earth's gravity pulls objects towards its center even without touching them. We can calculate the weight of the object using the equation W equals mg, where W is weight in newtons, m is mass in kilograms, and g is gravitational field strength in newtons per kilogram. Electrostatic force is the force between the charged objects. Charged objects attract or repel each other depending on their charges and distance between them. Like charges repel, unlike charges attract. Magnetic force is the force between the magnets. Magnets attract or repel each other without physical contact. Like poles repel, unlike poles attract. When a car is moving to the right as shown, there are the forces acting on a car including the weight acts downward, the total normal reaction forces acting upward at its wheels, the force from the engine acting forward, the air resistance acting backward. When a box is at rest on a rough incline as shown, there are the forces acting on a box including the weight acts downward, the normal reaction force acts upward perpendicular to the slope. The friction acts upward parallel to the slope. When we pull a box with a rope along the incline, causing the box to move up the incline, there are forces acting on the box including the tension acts up along the slope. The friction acts downward parallel to the slope because the box is moving up the slope. The weight acts downward. The normal reaction force acts upward perpendicular to the slope. When a box floats on the water, there are forces acting on the box including the weight acts downward. The upthrust acts upward. When a metal sphere is moving downward through the water, there are forces acting on the metal including the weight acts downward. The upthrust acts upward. The water resistance acts upward. Resultant force. The resultant force, or net force, is the single force that has the same effect as all the other forces acting on an object combined. If the resultant force is zero, it is called balance force. If the resultant force is not zero, it is called unbalance force. We can find the resultant force that acting on the object, for example. A box A has forces acting on it as shown. The forces on the left and right sides of the box are balanced. This means the net force acting on the box in the horizontal direction is zero. In the vertical direction, the resultant force can be found by subtracting the downward force, 22 newtons, from the upward force, 14 newtons. So, a resultant force is 8 newtons acting downwards. A box B has the forces acting on it as shown. The resultant force can be determined by adding the two forces acting to the right, 300 newtons and 60 newtons. So, a resultant force is 360 newtons acting to the right. A box C has the forces acting on it as shown. The resultant force can be found by adding the two rightward forces, 2 newtons and 4 newtons, and subtracting the leftward force 5 newtons. So, a resultant force is 1 newton acting to the right. A box D has the forces acting on it as shown. The resultant force can be found by subtracting the leftward force of 70 newtons and the leftward force 30 and 20 newtons. So, a resultant force is 20 newtons acting to the left. The three laws of motion, also known as Newton's laws of motion. Newton's first law of motion. The forces on an object are all balanced, then it will just stay still, or else it is already moving, it will just carry on at the constant velocity. When a car is at rest, then the forces on it must be balanced. So, car's weight acts downward to equal the total normal forces acting upward. When you pushes a car with a force 500 newtons to the right, and a car stays still, this causes the total friction between the tires and the road's surface to act to the left, 500 newtons, full balancing with the pushing force. When a car is moving with constant velocity, then the forces on it must be balanced. So, car's weight acts downward to equal the total normal forces acting upward. The force from engine, 2,500 newtons, acting forward is balanced with the fair resistance, 2,500 newtons, acting backward. When a ball is falling down with constant velocity, then the forces on it must be balanced. The downward weight, 10 newtons, is balanced with the total upward upthrust, 1 newton, and air resistance, 9 newtons. Since, we can conclude that, when no resultant force or balanced force, the object is stationary, or moving with constant velocity, and its acceleration is zero. Newton's second law of motion. If there is a resultant force, unbalanced force, then the object will accelerate in that direction. This acceleration can be done by changing the object's velocity. The change in velocity causes the object to start, speeding up, slowing down, stop, and changing direction. If a resultant force acts on an object at rest, the object will accelerate, starting to move, increasing its speed. If a resultant force acts on an object in the opposite direction of its motion, the object will decelerate, eventually coming to a stop. If a resultant force acts on an object in the same direction of its motion, the object will accelerate, further increasing its speed. If a resultant force acts on an object at a perpendicular angle to its direction of motion, the object will change direction, while its speed remains the same. The acceleration of an object is directly proportional to the resultant force. The bigger the force, the greater the acceleration. The acceleration is inversely proportional to mass of the object. The bigger the mass, the smaller the acceleration. This can be expressed mathematically as F equals ma, where F is the resultant force in newtons, m is the mass in kilograms, a is the acceleration in meters per second squared. For example, find the resultant force and acceleration of the box, with magnitude and direction like as shown. The resultant force is the subtracting the leftward force 15 newtons with the rightward forces 4 newtons and 2 newtons, resulting 9 newtons to the left. Calculate the acceleration using F equals ma. Substitute F equals 9 newtons, mass equals 2 kilograms. Then A equals 9 divided by 2 is equal to 4.5 meters per second squared to the left. Newton's third law of motion. When object A exerts a force on object B, then object B exerts an equal and opposite force on object A. A pair of forces must be equal in magnitude, opposite in direction, and act on different objects. For example, a book lying on a table exerts a downward force on the table. This is the action force. The table also exerts an equal and opposite force on the book in the upward direction. This is the reaction force. The earth exerts a downward force on the book. This is the action force. The book also exerts an equal and opposite force on the earth in the upward direction. This is the reaction force. While moving on the ground, we push the ground backward with our feet. This is the action force. The ground also exerts a forward force on our feet of equal magnitude in the opposite direction, which makes us move forward. This is the reaction force. A man's hand exerts a force on the wall. This is the action force. The wall also exerts an equal and opposite force on a man's hand in the backward force. This is the reaction force. A rocket exerts a downward force on the burnt gases. This is the action force. The burnt gases also exerts an equal and opposite force on the rocket in an upward direction. This is the reaction force. Friction. Friction is a force that opposes the movement of an object. It acts in the direction opposite to the motion. Friction is present almost everywhere, and it can slow down or even stop moving objects. This happens because friction converts kinetic energy into thermal energy. If there's no force propelling an object forward, friction will eventually slow it down to a complete stop. This is true on Earth, but in a frictionless environment like outer space, objects can continue moving indefinitely. To maintain a constant speed, an object needs a continuous driving force to overcome friction. There are 3 main types of friction. Static friction. This occurs between 2 solid surfaces that are at rest and not moving relative to each other. It prevents an object from slipping. Static friction is usually the greatest force you need to overcome to get an object moving. Kinetic friction, sliding friction. This occurs between 2 solid surfaces that are sliding past each other. It is the force you feel when you rub your hands together or slide a box across the floor. Kinetic friction is usually slightly less than static friction. You can reduce both static and kinetic friction by using lubricants like oil or grease between the surfaces. Fluid friction, also known as drag. This is the resistance an object experiences when moving through a fluid, liquid, or gas. There are 2 main factors affecting fluid friction. The surface area of the object in contact with the fluid increases, drag also increases. Streamlined shapes, like those of race cars or boat hulls, experience less drag. This is because they deflect the fluid more smoothly, resulting in less resistance to the object's movement. The object's speed increases, drag also increases.